In this video, we're going to talk about finding volumes of solids that are rotated about the x and the y-axis. So let's take a look at this this problem. It says the region that's enclosed by the two graphs, 64x to the 1/4 and y equals x. Notice that they don't give you any other information, like for instance where they intersect or things of that nature. So we're going to have to take a look at this, and we're going to assume that it's in the first quadrant. And of course it will be in the first quadrant because the this expression here to the 1/4 power is really that, correct? So because of that and the fact that it's an even index number in that radical, we know that it has to be positive. So that graph is going to intersect y equals x. Where is the question? So first step is to find the intersection points. So we set them equal to each other. So we're just going to set 64x to the 1/4 equal to x. So we're going to get rid of this fractional exponent by raising both sides to the 4th power, and of course that would get rid of the exponent on the left, and we would just be left with 64x equals x to the 4th, and that will give us x to the 4th minus 64x equals 0. And if we factor out an x, that would leave us with x cubed minus 64 equals to 0. And so the first solution is when this x equals 0. So we know our first solution is x equals 0, first intersection. And when we set x cubed minus 64 equal to 0, add 64 and take the cube root of that, x would equal 4. So we have our points of intersection, and we'll see if I can somewhat sketch this out a little bit. Well, the line y equals x is just going to go right down the middle right here, like so. And the 64 to the 1/4 is going to maybe look something like this. And they're going to have an intersection point right there. And it should be noted that the y value is also going to equal 4, right? You just plug in 4 to either one of these equations. Anyway, so there's our x and our y's, our intersections, and we should be able to proceed through with part A. So if you want to pause the video and give it a shot at any time, please feel free. But we'll set up the integral first, and then we'll look at part B. So part A wants us to rotate it about the x-axis, right? And recall that our dx's, we're defining it as this little vertical strip here, right, along the x-axis, since we're rotating about the x-axis. And we have this equation in terms of x. So each one of those little strips is our dx. So remember, it's the volume when we rotate it is all derived from pi r squared times h, and our h is our dx. And our radius, when we rotate it, our radius is going to be, let's see if I can somewhat draw this. We have a line down here, we had our blue line coming out here, and of course that would create some sort of a 3D shape for us. Anyways, so the radius is going to be, actually we have a large radius, which is the one furthest from the axis of rotation, which is the x-axis, and our little radius is going to be this little blue one right here, the straight line. So the way we're going to integrate it is simply, we're going to say that it is large radius squared minus the little radius squared and it's all going to be in terms of x. So we just fill in our information and proceed with caution. We should be fine. And we forgot our limits of integration, which is from 0 to 4. And that's the way we're going to proceed. So we have a quantity of 64x to the 1/4. But we have to square that entire thing. Try that again. Okay. And that's from 0 to 4. Let me just start over. That looks really bad. Start over. Volume is equal to pi from 0 to 4 of the quantity 64x to the 1/4 power, and that quantity is squared. Okay, minus our line squared, and it's all terms of dx. So there we go. So make sure we set that integration up properly. So when we square this, 2 gets distributed to that 1/4 exponent, and we're going to end up with 64x to the 1/2 power. And of course that's still just x squared. And we're still doing it from 0 to 4. And that's equal to our volume. So the square root of 64, of course, gives us 8. So all we have is 8x to the 1/2 power minus x squared dx. And now we can go ahead and take our integral. If you take a little bit of time to simplify it, you'll make your integration a lot simpler. So the integral of 8x to the 1/2 power, and we'll do it up here just to make sure. Integral of 8x to the 1/2 power. Just going to add 1 to that. 8 is still a constant. 1/2 plus 1 is the 3/2 power. Having trouble writing today. We have x to the 3/2 power. Now I'm having trouble finding the pen. Over 3/2. So we'll put the 2 up here, and we get 16/3 x to the 3/2. 16x to the 3/2 over 3. We can call that a constant if we like. And of course x squared is just going to end up being, this part here is going to end up being x cubed over 3. Alright, so let's see if we can do this over here. So our final equation is 16 over 3 x to the 3/2 power minus x cubed over 3, and we're evaluating that from 0 to 4, and that whole quantity is multiplied by pi. Alright, so plugging in our 4, this is where little arithmetic shortcuts are really helpful. When you plug in 4 and you raise it to the 3/2 power, then we have to subtract 4 to the 3rd over 3. And then when we plug in 0, of course, since x is up in the numerator, it's just going to end up being 0 minus 0. And then this whole quantity is still multiplied by pi. Alright, so back to this little shortcut here. Notice that you recall from algebra that you can raise 4 to the 3rd power, or you can take the square root of 4 first, since the denominator is 2. And of course that's a lot easier to do, because then you would have the square root of 4 is 2. Oops. Square root of 4 is 2. And then we're going to raise that to the 3rd power. So we get 8 times 16/3. Let's see if I can get some more room here. So we have 16/3. 16/3 times 8 minus 4/3 is 4 to the 3rd power is 64/3 minus 0, and this is all times pi. Okay. I don't know why I'm giving you all these shortcuts here, but I like to break this number up in 8 times 2. 8 times 2 is 16, so 8 times 8 gives me 64, and then if I double that, it's a little easier for me. It's 128 over 3 minus 64 thirds, have a common denominator. So 128 minus 64 will give us 64 pi over 3. And that should be our answer for part A. Okay, hopefully you got that when you tried it on your own. And now we're going to see if we can take a look at part B. I'm going to go ahead and erase most everything that we had from part A with the exception of the drawing so that we can talk about how to rotate it about the y-axis. So, let's see, probably need some room here. So the first thing we want to notice, that should be enough. We're not actually going to have to integrate it, we're just going to have to set it up. First thing we want to notice is that, see if I can erase just that dx strip we had. Of course not. Let me try drawing another line through there. See if I can make this happen. Well, anyways, close enough. So now part B wants us to integrate with respect to y, because we're rotating about the y-axis, not the x-axis this time. So in order for us to do that, we have to think about it. We're actually going to draw our strips. They're going to be drawn in the same direction as our axis of rotation. So since it's approaching the, looks like it's hitting the y-axis there, we need to think about it in terms of that. So basically just flip the graph, not flip the graph, but you know, our rotation axis is 90 degrees rotated. So we're going to talk about things in terms of y, and we noticed that our equation originally was y equals 64x to the 1/4 and y equals x. Well, to set it in terms of x equals something, it's pretty easy for the line because we just say x equals y, right? And that's going to be our blue line there. And then our red curve, how do we get it in terms of x? Well, just similar to the way we solved it before, we're going to raise y to the 4th power, and that will give us 64x, right? We take the 4th power of both sides, and then we'll just divide it by 4, our 64. So x is equal to y to the 4th over 64. Okay, now notice that since we're going to touch the y-axis with our equation, the one that's furthest from the axis of rotation is actually going to be our large R. So this time our big R is going to be the line x equals y, and the red curve is now going to be the tiny radius. So and now we're kind of lucky in this case because remember now our dx is actually sliding up and down because it's dy. So we're going to go from 0 to 4, but it's not the horizontal 4, it's this vertical 4 that's on the y-axis. So just sort of refresh your memory on that. So our integration is going to be as follows. We have the volume rotated about the y-axis is going to be pi times the integral evaluated from 0 to 4, and now the large R is going to be y squared minus, and the little radius is going to be y to the 4th over 64, and that quantity is squared. And then make sure we get maximum points. Don't forget to attach your dy there. So that's pretty much it. That's rotating it about the y-axis, and then the first part rotating about the x-axis. Okay, hope this was a good refresher and brought back some good memories about volumes of rotation.